Hi, welcome to Tech Dictate. Today we're looking at series and parallel connections of LEDs. So you're going to need a few things. First, you need a resistor, 200 ohm resistor, and then you need your breadboard and LED. So the breadboard goes for 300 shillings and the LED is 10 shillings each, and you'll need 9 of them. Then we have the batteries. The battery is 6 volts. You can use 9, you can use any, but 6 volts is what I'm using, so it will be easier for you to follow along with the 6 volt. Now, if you notice, I have connected several resistors together for me to get the 200 ohm. I will show you that in the tutorial. Since I did not have one that's 200 ohms, I decided to make myself one by combining a few. Yeah, basics of connecting resistors in series and parallel. Yeah, so actually it's going to be really about series and parallel because this is parallel. These ones are connected in parallel, and also the LEDs we're going to do them connected in both parallel and series. So let's get started. So we have this, okay, and we need them connected in such a way that the LED will not blow. That's why we need the resistor actually to limit the current. So we have this, and so we're going to calculate so that we know how I found that I need 200 ohms resistor. Now, you have your circuit, okay, 6 volts, that's the source. Then we definitely know we need some sort of resistance because what is this? The LED only requires 2 volts according to the ratings. Again, on the previous tutorial we talked about the rating, and it even gave you a site where you can always check. So 6 volts, 2 volts is only required. This also takes in 20 milliamperes. So now we need to find out how much resistance we need for this circuit. It's going to be this. So you have the total voltage minus VLED, that's the voltage of the LED, multiply it by the sum of all your LEDs. So in our case, it's only one. So this is number of LEDs. Then divide this by the total, okay? Sorry, by the current, okay? Which is this. So we're going to do 6 minus 2 divided by 0.02 amperes. We get our answer as 200 ohms. Okay, so that's how we get the 200 ohms. That's how we know we require 200 ohms for this circuit. We know the rating of the LED, and you also know the voltage supplied. Now, let me go to this. Now, how did I do this? Because I did not have the resistor, 200 ohm resistor, but I needed it. What I did, again, if you remember your series and parallel circuits, when you connect resistors in, okay, so we have, I will just tell you all these resistors. 3 of them are this, and this are 1000 ohms, and this is 500 ohms. So I connected them in parallel. Okay, so this is 1K, 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 and oh god, I think it's not very visible. Now it is. So 1K and 500 ohms. Okay, now the total resistance is equals to R1 plus 1 over R2. This is when it's in parallel, plus 1 over R3, and so on. Now this will be 1 over 500 plus 1 over 1000 plus 1 over 1000 plus 1 over 1000. And this will give us the 1 over 1000. Let me just do the whole thing. This will give us 200 ohms if you do it in your calculator. Okay, this is 2. I think I've not written it so well, but this is 200 ohms. And so that's how I found this to be 200 ohms. First, I just tested them. Okay, I did not really do even the calculation first. I just went to the resistors I had, and then, like, what, I don't know how it's called, but I just tested. Put two together, see how much it adds up to. Put two again, see how much it adds up to. Now, the basic principle is it will always be lower than the lowest. So, for sure, this would have been lower than 500, but I don't know what value. So if I wanted something greater than 500 but less than 1000, then probably 1000 would be the lowest I would have used. I don't know if it's making sense, but that's the concept. Like, it's always lower than the lowest value when you put them in parallel. But in series, it will add them up. So if I had two 100 ohm resistors, then I would have to add them up to be 200 ohms. That will be connecting them in series. Okay. So if this is 100, okay, if this is 100 ohms and this is 100, this is 100 ohms, then connect them in series. It's 100 plus 100, 200 ohms. Okay, so depending on what you have, that's how you choose which method to work with. Yeah, so that's how I found my resistor, and also I found my resistance. So I think we can get started on the connection. So take this, okay, you have that, so you connect your resistor to the, again, I will just repeat what I mentioned in the previous video. You have the short leg and the long leg. The long leg goes to live 5 volts VCC, all that. And then this other one goes to ground. Okay, so in our case, I'll just connect the long leg to the resistor, and then the other leg of the resistor, the connection of the resistor does not really matter. If whether it faces this way or this way, it doesn't matter, it does the same thing. So then I connect the LED, no, the other leg of the resistor. One leg is connected to this LED, the long leg of the LED, and the other leg of the resistor is connected to the red wire, that is 6 volts, and then this other one to ground, and our LED lights up. Don't know if you can see it lighting up. If I remove it, it goes off and then it lights up. So this is how I'm going to do my testing and find the LEDs we will be using for this session. So we have all the LEDs we're going to use. That is 9 LEDs. I combined them with the green ones, which require a little bit higher voltage. That's why they're not really lighting up as bright, but as long as it works, so it's going to prove our concept. But we're going to connect them in series and parallel, and so let's get started with that. I will just explain it first, and then we proceed. So we talked about, I have 6 volts as my source, and we said in series we sum them up. Okay, so we have this current in voltage in series is added, okay, across the components, and then in parallel it remains the same. So if I connect these 3 in series, that means the voltage required will be let me assume this is also taking 2 volts in, okay? Because it takes 2.1, but let me assume it takes 2 volts. So if they're connected in series, then it will be 2 plus 2 plus 2, which will be 6 volts. That means this source will be able to provide without the need of a resistor, because this is 6 volts and this is 6 volts, okay? Now, when they're connected in series, okay, they sum up. But then if they're connected in parallel, that means each will only take in 2 volts and therefore will need a resistor, okay? But if I connect all these three together, then connect them in parallel with another 3, right? Connect them in parallel with another 3, then that means that the voltage of this 3 will be 6 volts, okay? Then the voltage consumed by this other 3 will be 6 volts, okay? Because we have this, right? These ones are in series and therefore they consume 6 volts. So therefore, 6 will be supplied to this. However, when we've said if they're connected in parallel, the voltage remains the same. So 6 volts will also be supplied to this next chain. And therefore, this will take in 6 volts and this will take in 6 volts. And since this added together is 6 volts, we need no. And our source provides 6 volts. Sorry, I forgot you were not able to see that. And since our source provides 6 volts, then we need no resistors. Or maybe you can just put a small one to just in case it's higher or these ones take low a little bit lower. But that's the concept we're using to connect our LEDs today. Okay, so we have 6 volts as our source, and we have this taking 6 volts and this taking 6 volts and the next one taking 6 volts. So these ones are connected in series so that the voltage is summed up, but these ones are connected in parallel and so the voltage remains the same in each. Yeah, so I think we can do that. Let's connect them. Oh, I forgot to mention you're going to need these jumper wires or just any jumper wires or just wires like this so that you can make your connections to the battery source, to the power source. So the short legs, all the short legs get connected together on this rail and all the long legs get connected together on the upper rail, okay? So I will, when the long legs connect to the 5 volts, as I mentioned earlier, and so in our case it's 6 volts, and so I will connect them that way, and all the short legs get connected to the other one, and that is it, okay? So that is what we have by the end of it. So as you'll notice, they light the same exact manner. Let me just switch this off. Yeah, so as you'll notice, they're lighting the same amount of brightness. That means 6 volts is going through each, okay, this line. Okay, so we have, let me just make them look a little bit tidy. So this one 6 volts, the second one 6 volts, and the last one 6 volts on each. And that's why they're lighting with the same amount of brightness. And 6 volts with no resistors because each takes in 222, 222, 222. And that's why they're able to light up this way. If you mess the connection, then they may blow up, so please be careful. Follow the connection on the screen to make it to make this. Yeah, I think this is it for this tutorial. We've just explained series and parallel connections of both resistors and LEDs. It's similar to most things. So yeah, I think that's it. Let me see you in the next tutorial. Don't forget to subscribe and follow and click the notification button for more tutorials.